Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now, many types of applications that you'll wind up writing involve text, whether it's text that you'll need to feed into other applications, or text that you'll retrieve from end users, or text that you will actually format for display to an end user. So there's this notion of massaging data, changing it in subtle ways in order to format it specifically for input to another software system. Professional software developers spend a lot of time taking data, changing it in some way, and then putting it into another format for ingestion into another software system, or formatting the data for display, or looking at the data that's been input or by an end user or by another system and ensuring that it's in the right state, that it looks correct in order for it to be used inside of our application. So mastering the manipulation of strings is a vital skill in Visual Basic. Furthermore, the string data type can hold a lot of information. It's actually, when you compare the buckets and the sizes of the buckets in the computer's memory, the string bucket is a massive bucket if you want to continue that analogy. So efficiently working with strings is another vital skill in Visual Basic. And in this lesson, I'm going to demonstrate several common string manipulations that are made easy by both Visual Basic proper as well as the .NET Framework class libraries and the inherent functionality that it baked into the string data type, the string class. Okay, so you can see that I've already created a new project called Working with Strings, and we're going to do several different things. We're going to work with special characters inside of our literal strings. We're going to format strings for display using the replacement syntax that we've already looked at a couple of times. We're going to look that it has actually more functionality than what we've seen up to this point. We'll look at just basic string manipulation, pulling things out, putting things in, breaking it apart, things like that. And then we'll take a look at working with large strings more efficiently by using a special class called the String Builder. All right, so let's begin by looking at how we work with literal strings and special situations with literal strings. So for example, I might create my string equals my so-called life, and I have a couple of options here. If I want to say this in an ironic way, I could separate so-called using a single quote, but what if I needed to use a double quote? Unfortunately, if I use double quotes, it's not going to look quite right, and I'll get some errors here because we're not able to tell the Visual Basic easily that we just want to use a double quote here inside of our literal string. So to fix this, you can escape double quotes by using double quotes together. So when I pair up double quotes like so, we're saying we want this to be treated as a double quote inside of a literal string. Same thing with this second instance right here. And so we're able to treat the whole thing as a literal string. And if we were to print this now, let's go console.writeLine my string, and we'll go console.readline. It will actually print out correctly for us. And I just hit the F5 key on my keyboard to run it instead of hitting the little run button, the start button on my toolbar. And you can see it formats it correctly, my double quote, so-called double quote life. Great. All right, so next up, let's comment that out, and we'll take a look at what if I need to add a new line or a line break in between a literal string. So here I might have my string equals what if I need a new line. All right, and I want to put maybe that new line character right here. How do I do that? Well, we've already seen the little technique that we've used to kind of add two literal strings together using the ampersand character, right? And so what we can do is actually in between the ampersand characters use the special constant called VB new line. All right, and there's a bunch of these little constants that are available for VB. If you type in VB and you look in IntelliSense, some of these have very specific usages that may not make sense here, but I'll show you a couple of these throughout the remainder of this lesson. But for now, we just need something that that tells Visual Basic that we want to create a new line right in the middle of our literal string. So let's go ahead and run our application now, and you can see that we were able to break onto a new line, even though it's one literal string here that we created on line number 6. All right. What if I need to add a tab in the middle, a tab spacing in the middle of my literal string? So what if I need a tab in my line? So the same thing would be true here. I'm going to go ahead and start the process by splitting these two segments into two literal strings and appending them together using the ampersand. I'll add a second ampersand and glue them together with then a VB tab. So another constant from Visual Basic, the VB tab constant, and now when we run the application, you can see that it puts a tab spacing in between the two segments of my literal string. Okay, so that's how you insert these special characters or these special situations into your literal strings. All right, next up, let's talk about the formatting, the special formatting that we did inside of strings using, remember, console.writeLine, and we were able to say, hey, there's this replacement syntax, and I can replace that with something like Bob. So I can do hello, comma, and then the replacement code 0. Whoops, and let's go ahead and just remove that part. So we did that, right? And we could see something like this, right? So what if, let's get rid of that, and let's go back down here. What if I need to do that same sort of replacement code, but inside of a literal string? Instead of using console.writeLine, because you saw that wouldn't work, I can use string.format, and it's identical. We can do the same sort of thing with that. So hello, comma, replacement code 0, Bob, exclamation mark, and let's go ahead and dim this. String equals string.format. There we go. That's the correct incantation. And we get the results that we're looking for. So string.format will allow us to add the little replacement codes, the formatting replacement codes here inside of a literal string. Here I just used another literal string, but we could use a variable or whatever. All right. So that's a very simple case, but let's look at some more interesting cases. So for example, we already looked at an example where we were able to use multiple input parameters. So string equals string.format, and then we were able to do something like the make 0, the model 1, and the maybe even year 2. Of course, this is 0 based, and we will do, so we have a very specific format that we want to print our string to screen. And then we can also then add in the values that we want. Like for example, BMW, 745 Li, and 1995. All right, and let's go ahead and put some of these on separate lines so you can see them. So I'm going to add a line continuation character right after the equal sign. And then I'm going to go ahead and split these off into different lines as well for readability's sake, like so. So this is all one line of code, even though I split it off into multiple lines. And now let's see what we get whenever we run this. And the key notion here is that we're able to insert multiple replacement codes inside of a literal string by just supplying then a list of input parameters after the template that contains the replacement codes. It's 0 based, so the first item, the second item, the third item will be replaced in to those replacement areas that have the curly braces and the index. Now we can mix things around. For example, like I could take the 2 and put it here, and take the 0 and put it there. And then I could also use the same replacement code twice inside of the same string, so that I could essentially use that same number 1995 2 times. Of course, this will be nonsensical because the make is not 1995, but you can see at least I'm able to switch around the order. It does not have to be just in the exact same order as inside of the template as we have the items that we're passing in. But this is still element 0, 1, and 2. We're just putting them in different places inside the template and even reusing them multiple times. All right, let's comment all of that out. And now let's take a look at an even more interesting usage of this. So my string, and say that we wanted to format a string for a specific purpose, like we wanted to take the number 2335, and this number, we want to represent it as currency. So in that case, inside of the replacement code, we're going to use the colon and then a special replacement code formatting syntax. And this will represent this as currency. Now, if you're in another country, and for example, if you're in Great Britain, it will represent this based on your operating system's locale feature. So you may have it represented with the British pound sign as opposed to American dollars with the dollar sign. And so it's smart enough to know how it should be represented on screen. In this case, you can see the dollar sign 2335. All right. Here we're going to do the same thing, dim my string as string. Now, you may have noticed here that I was able to do this and not declare a data type. I don't recommend that you do that. It's kind of an advanced topic to explain what happens when you don't do that. I don't want to get into that right now. Let's just go ahead and fix the code. But that was my mistake, but it'll still work, okay? But it has a different connotation and some downsides, so we'll just not do that. All right, next up, let's format this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, but let's format it as a real number with commas and decimal points at the right spots. All right, so I'm going to use this special format code colon capital N. All right, and so now let's run this, and you can see that it makes it into an easily readable number of 1,234,567,890.00. Okay, so that's the N formatting code. And then here, dim my string. What if we needed to represent a number as a percentage? So string.format, and we want to take the number 0.123 and represent that as a percentage. So again, we'll start with the replacement code 0, but I'm going to use colon P this time. And now you can see that it will print out the number as 12.30 or 3% with the percent sign. It also uses the decimal place in the correct spot. So that's how you work with the replacement code and the formatting of a percentage. And then finally, you can create your own custom templates, I guess you can say. Replacement codes using, for example, I want to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I'm going to create a phone number. So I want to use the way that you would represent a phone number in the United States. Which is 3 digits for an area code. So I'm going to use ###, which means just 3 numbers, the first 3 that you have here, and then a space, and then ### dash ###. Okay, so that's the format of a phone number. I could even do something like this, phone colon, just to kind of flesh out this example a little bit. All right, so now let's see that in action. Let's run the app. And whoops, didn't do something here. Oh, that's right. All right. I didn't give it the replacement. So here's what we need to do. Wrap a curly brace, set of curly braces around it, 0, and then colon. And now this becomes the template for the replacement code. Okay. Now let's run the application. And you can see it formatted it using the numbers that I supply. What if I were to supply more numbers, we'll put a 1 here at the end, than what the template can hold? Let's see what happens. What's the behavior here? Well, notice that it pushes it to the very, it pushes it from right to left. So it's going to honor the template from right to left. Now it's going to push more digits into that area code area, unfortunately. It's not what we would probably want. However, we should probably validate our data to make sure it's an actual valid phone number before we do any formatting about it, formatting with it. All right. All right, so moving on, we're going to talk about dealing with strings, large strings. We already said that the string bucket is very large. The problem with working with strings is that they are what's called immutable. So whenever I put a value inside of a bucket that's holding a string, or a variable that's holding a string, if I want to change what's in that bucket, I essentially, what's going on behind the scenes, the .NET runtime is going to create a second bucket. It's going to pull all the values into the second bucket, plus the new value that you want to append to it, and then it's going to remove the old bucket, and then it will change the label on the new bucket. And so it does all this for you behind the scenes, but it's a very intensive process to make changes. So if I were to do this, for example, just to kind of illustrate what you should not be doing, and let's go for tab index equals 1 to 100. And inside here, I'm going to go myString plus equals, or actually ampersand equals. So take what the current value of my string is, and I'm going to add on the index. Now I'm going to convert that CSTR to a string, okay? So that I can take this numeric value and then convert to a string and then append it onto the end of this string. Plus, I'll go ahead and append on a dash dash, just so we can kind of see that in action, like so. All right, and then we'll run the application, and you can see that it'll do it pretty quickly. We get from 1 to 100 with double dashes in between, but what we had to do, that little maneuver behind the scenes 100 times, and unfortunately that will be very processor and memory intensive. That's probably not the way that we want to append a lot of strings together. Instead, we can use a special class whenever we're working with a lot of strings, and we're going to do a lot of appending of strings, and we don't want to take up more memory and processing power from the computer than we absolutely have to. So we're going to use a special class called the string builder. So here in this case, instead of declaring my string as a string, I'm going to create it as string builder. And so in this case, you'll see that I'm going to type this class name string builder, but it cannot find the string builder class in the .NET Framework class library. Now the reason for this I'll explain later, but notice that as I hover my mouse cursor over it, it shows a red squiggly line. And this tells me there's an issue. The type string builder is not defined. Now I know that it exists in the .NET Framework class library. So what I'm going to do is actually utilize this little light bulb that popped up underneath the word string builder. And it gives me an option to either do one of two things, actually several things, but these first two are the most important. I can either say, give it to me because I know it exists in the system.text.stringbuilder namespace. Whoa, what's a namespace? We'll talk about namespaces later. So it's like a last name for your classes, all right? Or, as you can see, I can, as I get the little light bulb popping up here, I can import system.text. And when I do that, it will add this little line of code at the very top, the very first line of code, to import that namespace so that it can find this class inside of the .NET Framework class library. So, like I said, the class name is string builder. I know it's somewhere in the .NET Framework class library. I just have to go to the right shelf on the library to find that class. All right, and so that's all I'm saying here. Hey, go to the system.text shelf, and you'll find a class named string builder there. So we're just giving a little extra instruction to Visual Basic to where it can find this string builder class inside of the massive library of functionality that Microsoft gave us. Okay, so we'll just do that. And now that we've included or found that, I'm going to actually do as new string builder. Again, we'll talk about the new keyword a little bit later. And this time we'll go for tab, index equals 1 to 100, enter. And inside of here, what we'll do is myString.append. So we're going to use the append method, and it's more memory friendly than using the ampersand equals in order to append two strings together. This will not perform that little dance in memory that we suggested earlier. So in this case, all I need to do is use the index. All right. And I don't even have to do that little conversion, but I'm going to anyway. CSTR index to convert that number into a string, and then myString.append, and we'll go with the literal string dash dash. Now the result will be identical. However, you're going to see a strange behavior here at the very... No, it didn't. Okay, very good. So you can see that we were able to get these exact same results. It was just much more memory friendly than doing it this way, okay, using the string builder. All right, well, let's continue on. I'm going to comment all that out and move on and talk about doing some string manipulations by being able to identify or manipulate the certain parts of the string. So I'm going to start off with a phrase from a song that I like. I'm going to add a space, and then last summer we took threes across the board, period, space, space. All right, so I have a leading space in front of this phrase, and then two trailing spaces at the end. And we'll look at how to trim those off in just a little bit. First thing that I want to do, however, is set my string equal to just a subset of these. So I just want to pull out certain words or certain phrases inside of the string, and I can use myString.substring. Look at that method that it gives us, and I can choose to say, hey, start at position number 13 and return back everything, count 13, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bring back everything after that and then print it to screen. And you can see we did that. I can also say, well, this is the starting point, but I can also give it an ending point as well. So I'm only going to choose 15 characters then and print those out. So we took threes as opposed to the entire message. I just grab off 15 characters, put them in my string. I can do something like this. My string equals my string dot to upper, and that will make the entire string uppercase, like so. Or conversely, I can make it all to lower, like so, and it's all lowercase. Furthermore, I can replace characters. So my string equals string.format. Whoops, I'm sorry, string. Let's start that over again. My string dot replace. And what I want to do is search for the old character, which will be just a normal space character. And I'm going to replace it with double dashes. So for every space that we see, it'll be replaced with double dashes. And you can see then we get the following with 4 dashes here at the very end, because we had 2 spaces here at the end of our original string. And, you know, one of the other things that we can do with strings is get the length. So for example, let's go ahead and do my string equals string.format, and I'm going to say my string is so many characters long. All right, so we'll start there and say, show me my string dot length. Just like we used with the array to see how many elements are in the array, we can also do that with a string. Again, a string is just really an array of individual characters, right? So we can see how long, how many characters are actually in the string and print that out. my string is 47 characters long. Very cool. Okay, now what I'd like to do, I'd like to use the trim function, and so we're gonna just add on to this. After trim, then we're gonna print off the length of our string. So what trim will do is actually remove any of the leading and trailing spaces for a given variable, or in this case, a literal string. And then it will return back the new string without those leading and trailing spaces. However, in this case, since it returns a string, I can continue to call another function or property of the string, and I'm going to call length again. So I'm chaining together commands. This is a string. This method operates on the string and then returns a string. And since it returns a string, we can then go ahead and call another method that we get access to from the string class, and that is the length. So here we go, and we'll run it this time. And so we've cut off 3 characters, and so you can see after we've called the trim, it's only 44 characters long. Okay. All right, and so we can also, just so you know, do mystring dot trim. We can only trim off the start or trim off the end. Okay, so you have some options there. You don't have to trim all the spaces. You can just do the first or the last spaces using the trim start or trim end. All right, so that's pretty much all I wanted to show you, but ultimately I would say that you should take a few moments and look at the other functions that or methods that are available on the string class, and just take a moment to learn about them, because there's a lot more that you can do. Some of these won't apply, but some of them will. And before you go and just start trying to manipulate strings and you know, write like more than 1 line or 2 lines of code to make some significant changes to strings, just remember that you could probably find an easier way to do that just using the built-in string method. You may have to get a little creative sometimes, but you definitely can figure out how to manipulate the string to make it exactly the way you want using the built-in functions. You just have to find the right combination of functions and call them in the right order, and it'll probably make your life a lot easier. All right, so that finishes up our discussion of manipulating strings. Let's do the same thing with dates and spans of time in the next video. We'll see you there. You're doing great. Thank you.